So the big thing that stops students from getting verifying trigonomic identities correct is the rules. Okay, and I know they're weird at first, but once you get used to them, you'll know what Alex is looking for. Algebra is where you do something that doesn't necessarily involve trigonometry. So if you had, let me think here, if you had like sine x plus 1 subtracted by sine x, and then the next step you simplify that to be, this is an example. If you simplified that to be 1, you did some algebra because you subtracted two terms that were the same. Okay, sine x subtracted by sine x makes 1. So anytime you do some sort of manipulation that doesn't really involve trig, that's probably algebra. Okay, like rewriting things. Like another example, I think this one comes up pretty often. If you have sine x plus 1 over cosine x, and for some reason you wanted to write it as sine x over cosine x plus 1 over cosine x. That's algebra. Okay, didn't do any trig. You just use the idea of fractions, that if you have two terms in the numerator and one in the denominator, you can write it as sine x over cosine x plus 1 over cosine x. Break up the fraction. That's algebra. Okay, reciprocal is a trig thing. I'm going to abbreviate so you don't have to painfully watch me right there. Reciprocal is where you use the reciprocal trig functions. When you write sine x equals 1 over cosecant x. Okay, that's a reciprocal definition for trig functions. If you write secant x in your next step, you write it as 1 over cosine x. That's using the fact that secant is a reciprocal of cosine. Okay, quotient, that's when you use the fact that sine over cosine is tangent, or cosine over sine, that's equal to tangent, so cotangent, sorry. Okay, that's what they want when they say quotient. Let's see what else we got for rules. We got the Pythagorean. There's 3 of them, unless you want to rearrange them in some crazy way. Okay, and the most common one is that sine squared x plus cosine squared x equals 1. Okay, so if you see sine squared plus cosine squared, and in the next step you replace that with 1, you've used the Pythagorean identity. Okay, so when you see squares, that's usually talking about the Pythagorean identity. Okay, so the other ones we have are like, I think Alex presents it like this. You could rewrite this algebraically, but if you have tangent squared x plus 1, and you say that's equal to secant squared x, that's a Pythagorean identity. Cotangent squared x plus 1 equals cosecant squared x. Okay. Just remember, tangent and secant go together. Cotangent, cosecant go together. That'll help you with the Pythagorean identities. Okay. We'll probably refer to those a couple of times when I do some problems. And then odd, even. These aren't used as often. Okay, sine is odd. So you use the, I'm using the wrong button, that button right there. Okay. So this is where if you have sine of negative x, you use the fact that sine is odd to rewrite it as negative sine of positive x. Or if you have a negative inside the cosine argument, that's the same thing as positive cosine. That's because cosine is even. That one's used less often with these verifying trig identities. Okay, so let's try a couple problems here. So they've already got the steps listed out. So 1 minus cosine squared x, that got changed to sine squared x. So that's a Pythagorean identity, okay? It's not immediately clear, but if you look at it, you could rearrange this by subtracting cosine squared x from both sides, right? You get sine squared x equals 1 minus cosine squared x. So we're using the Pythagorean identity to rewrite that. And then here, sine squared x equals cosine squared over sine squared. Now cotangent is cosine over sine. So cotangent squared is cosine squared over sine squared. So that is the quotient identities we were talking about, using the fact that cotangent is cosine over sine. And then looks like algebra here. Sine squared times something over sine squared, those cross cancel. So no trig happened there. That's just algebra. Okay, let's try another one. So if you have 1 minus tangent x being squared, okay, they rewrote it like this. And that's probably tough to see where they got it from unless you've been doing algebra for a while. What they did was if you square something, you multiply it by itself, right? So 1 minus tangent x squared, that's the same thing as 1 minus, oops, that's the same thing as 1 minus tangent x times itself times 1 minus tangent x. I don't know why I'm writing 2. Okay, so if you multiply these out and combine like terms, well, if you multiply them out, 1 times 1 makes 1. 1 times negative tangent x makes negative tangent x. And then negative tangent x times 1 makes negative tangent x. This should feel like back when you were doing factoring, you know, multiplying two parentheses. Negative tan times negative tan makes positive tan squared x. So what they did was they simplified this just algebraically. Didn't use any special trig rules. And then they used, let's see, so you got negative 2 tangent x. 1 plus tangent x, that's this Pythagorean identity right here. Right? 1 plus tangent squared x is secant squared x, so that's a Pythagorean identity. So it's really about knowing what those rules mean, because then the next step is eventually we're going to do proofs where you have to do the statement column and the rule column at the same time. So same thing up here, okay? You got cosecant squared minus 1. So that's it, this Pythagorean identity. If you just rearrange it, if you subtract 1 from both sides, cosecant squared minus 1 is cotangent squared x. So that's Pythagorean. And then they rewrote cotangent as cosine over sine. So that's one we've done already. That's quotient, right? It's that quotient rule we talked about. And then cosine x over sine x is cosine x. So they got a sine x times something over sine squared x. One of those sines canceled out. So it looks like from this step to this step, they just rewrote it algebraically. They took one of the two cosines and wrote it out front. And then they also canceled out one of these sines through cross cancellation. So that's just algebra. And then we got quotient again. Cosine over sine, that's cotangent. That's the definition of cotangent. So that's the quotient identity. Okay, so just really take some time learning what all those rules mean. You can feel free to let me know if there's another problem you want me to